Good morning. Today we're going to discuss right triangle trigonometry. Right triangle trigonometry was originally started by the Greeks, so in theory we could go out and start drawing triangles in the dirt. So let's go ahead and look at some right triangles. Alright, let's start by defining our right triangle. The right triangle has two short legs and one long leg. So this is one of our short legs. We're going to go ahead and label it with an A. This is another, what we call a short leg. We're going to label him a B. And then finally here we have the long leg. We're going to label that one a C. And that leg is typically called our hypotenuse. Now, Pythagorean's theorem tells us that the long leg, so get the pen back on this, here we go, c squared is then going to be equal to a squared plus b squared. So if you're given two sides of the triangle, you should be able to find the third side. We also have information about the angles of this triangle. Now we know one of the angles, this one right here. We typically put a square there, and that means that it's a 90-degree angle. We then have two other angles. Let's go ahead and label those alpha and theta. All right, we typically use our Greek letters to label our angles. So if we have that right triangle, a right angle is 90 degrees. If we add the other two angles to that 90 degrees, we add our alpha and our theta. What's the result? The result then should be 180 degrees. Okay, so this is the basic information we then need to start working with those triangles. Now remember, this is trigonometry. So back when we were working with functions such as a parabola has an x squared, we're now going to learn some new functions with some interesting names. So let's go ahead and take a peek at those. Alright, so here are our right triangle definitions for our trigonometric functions. So why don't you go ahead at this point, pause the video, get these written down in your notes, and then go ahead and come back and we'll get started talking about them. Alright, now that we're back, let's go ahead and start talking about these. And to do that, I'm going to go ahead and give myself a triangle to talk about. Alright. Let's try that one more time. There we go. Alright, let's start talking about this triangle. The triangle basically has three sides, and when we talk about opposite versus adjacent legs of the triangle, really we're talking about it from our vantage point. So let's go ahead and let's say this is the angle we're using, and we'll label him an angle theta. And when you look at these various trigonometric functions, you have to imagine that you are a stick person, and you are sitting here at this angle theta. Alright, so you're sitting here at this angle theta, and when you look out from the angle theta, this side here is then going to become your opposite side. And this side down here is then going to be your adjacent side. Alright, and then this side here is our hypotenuse. So let's go ahead and look at these. If we look at them, the first one here, what's going on here? We have sine of theta is the opposite over the hypotenuse. So what's happening with this when we take, for example, a sine function, let's get a darker color. If we take a sine of theta, you're going to literally read the numbers here right off the triangle. You're going to get this number for the opposite side and this number then for the hypotenuse. Let's go ahead and actually work through one of these. Now let's remember what those functions are, and hopefully you've got them in your notes so you're good to go. So let's talk about what are the 6 trigonometric functions for the following triangle, and of course we need a little bit of information here to do this. So if we make this angle here theta, then this side here is going to become 5, and this side here is going to become 13. But what do we not know? We don't know what our adjacent side is. How are we going to find that adjacent side? Well, we're going to go back to Pythagorean's theorem. And that's going to tell us what? It's going to tell us that if we have 5 squared plus our a squared, that's going to equal then 13 squared. 5 squared is then going to be a 25 plus an a squared is going to equal 169. Subtract 25 from both sides, and what's the result? The result is then that we have an a squared equals 144. When I take the square root of both sides, a then equals 12. Now I understand that when we take the square root, usually we write it as a plus and a minus, but not here. Now we're only going to look at the positive aspect. If we had a negative 12 as a side, I think we'd black hole or something. So that's a positive 12. At this point, we can go ahead and we can write down our 6 trigonometric functions. And let's remember what they are. Our sine of theta, if you look back at your notes, what's the sine of theta? It's the opposite over the hypotenuse. So for this case, it's going to be then 5 over 13. Cosine of theta is then going to be the adjacent side over the hypotenuse. So what's that one going to be? That one's then going to be 12 over 13. And then let's look at our tangent of theta. Tangent of theta is then equal to what? That's equal to the opposite over the adjacent. All right, and what is that going to be? That's going to be 5 over 12. Let's just pause here for a second and talk about where these numbers came from. These numbers are coming right off my triangle. I am reading them right off the triangle. So when you take your quiz or your exam, best thing to do is sometimes start by drawing a triangle. We have 3 more functions. I call these the kissing cousin functions. Cosecant is the first one. That one is then going to be our hypotenuse over the opposite. So that's going to be then 13 over 5. I want to point something out here. If you notice, these 2 functions are reciprocal functions. And when we do, in the next section, when we look at the trigonometric functions, you'll see how they are directly related as reciprocal functions. Let's do as the secant. That's going to be the hypotenuse over the adjacent. Remember, it's kissing cousin. If we look carefully, it's going to be the cosine here. So that's then going to be 13 over 12. And then finally we have cotangent. And as the cotangent's name implies, that's then 1 over the tangent. So that's then the adjacent over the opposite. So that's then going to be 12 over 5. All right, so we have successfully completed this problem. We have written down all 6 of the trigonometric functions.